Welcome back, Chem 30. This demo will be the start of Booklet 10.3. So this deals with precipitate formation and spectator ions and the different types of equations we'll look at. So here we go. We have two different solutions here. They're clear and colorless. This first one here is lead nitrate. And I write a little AQ here because I took solid lead nitrate and dissolved it in water. And combined with potassium iodide will be this other solution. Okay, so clear and colorless, clear and colorless. And when I combine them both, isn't that neat? We get a yellow solid being produced there. So it's a precipitate. Now the possible combinations here, if I look at the ions I'm dealing with, it's lead 2, so from your pink sheet, Pb2 plus, NO3 minus are my two ions there. K plus is potassium, I minus is the iodide ion. So of course we can see the two combinations here for this double replacement reaction. So Pb and the I will come together to form lead iodide. Now this is worth 2, this is 1, so I need 2 iodides to make this work. And then combined with potassium, K plus, and nitrate, NO3, simply come to make KNO3. And over here I have 2 nitrates, so I need to put a 2 here for 2 nitrates, 2 potassiums, 2 potassiums, 2 iodides, 2 iodides. So this is called the balanced chemical equation. So this is what we would have dealt with in Chem 20. It's also what we did with the Chem 30 review. Basically shows a double replacement reaction. Now, you don't know this yet, but the lead iodide is actually the precipitate, so I'm going to write a solid there, and AQ here because that exists in ion form. Okay? Now we don't know why that is so yet. That will come up with the lab that we're going to be doing after this particular booklet. For today I just want to look at the balanced chemical equation and then look at two other equations that are very important here. The first one being the complete Ionic equation. So underneath here, complete Ionic equation shows all compounds in ion form except the precipitate, and I like to use PPT as shorthand for precipitate. So if I'm going to look here, lead and nitrate, we could write it out like this. Just move that. So here's an example of this type of equation. So Pb2 plus, write a little AQ, and nitrate, AQ. Now if I look up here, for every 1 lead I need 2 nitrates, so I put a 2 in front of there. So that is my lead nitrate section, combined with potassium iodide, K plus, AQ, and I minus, AQ. If I look up here, I had 2 potassium iodides, so that means 2 Ks and 2 Is. Yields, now my precipitate, I just rewrite it as is and leave it together. And KNO3, K plus, AQ, plus NO3 minus, AQ. And of course here I have 2 Ks and 2 nitrates, so I put my 2's in front of there. So that is my complete Ionic equation. The first two compounds in the reactant split off into ions, my precipitate, and my other two ions. Okay? Now we'll notice something here. There are two, so the lead and the iodide come together to form the precipitate. The two K pluses remain unchanged. The two NO3s remain unchanged. So they are referred to as spectator ions. Spectator ions. Spectator ions do not participate in the formation of the precipitate. So they're just kind of sitting around. And what I'm left with after I cross those off is referred to as the net ionic equation. Which illustrates the precipitate and the ions that made the precipitate. Okay? So overall, I mixed everything up. I got this precipitate formation here. We have our balanced chemical equation to start off with, and that turned into the complete ionic equation, which shows all of the ions and the precipitate just as is. And then finally the net ionic equation, which shows the precipitate and the ions that made the precipitate. Okay? See you again.